Hello everyone. In this topic we are going to see about understanding virtual machines. So understanding virtual machines is a crucial for anyone working in IT, software development or cyber security. So virtual machines allow multiple operating systems to run on a single physical hardware platform, enabling more efficient resource utilization and flexibility in managing computing environment. So first we have to understand what is virtual machine. So a virtual machine is a software emulation of a physical computer. It runs an operating system and applications just like a physical machine, but it exists within a software environment, allowing multiple VMs to operate on a single physical server or host. So the key components are, first one is the hypervisor. So hypervisor is nothing but it is a tool used for creating and managing the virtual machines. So there are two types. So type 1 is a bare metal. It runs directly on the hardware. For example, VMware ESXi, Microsoft Hyper-V. So type 2 is hosted. It runs on top of an existing operating system. For example, VMware Workstation, Oracle, VirtualBox. So next one is the guest operating system. So the operating system installed on the VM, which can be any compatible OS such as Windows, Linux or Mac OS. Virtual hardware. So each VM has virtualized components like CPU, memory, storage and network interfaces simulating the hardware of a physical machine. So next one is the architecture of virtual machines. So the architecture of virtual machines has several layers. So host machine. So the physical computer with its hardware, CPU, RAM, storage running the hypervisor. Hypervisor layer. It manages the VMs, allocating resources and ensuring isolation between them. Virtual machines. Each VM operates independently with its own virtual hardware, guest OS and applications. So next is the benefits of using virtual machines. First one is the resource utilization. So VMs allow multiple OS instances to run on a single server, optimizing hardware usage and reducing cost. Isolation. So VMs are isolated from one another, meaning issues in one VM. Example, crashes or malware do not affect others. Flexibility and scalability. Easily create, modify or delete VMs based on changing needs without significant hardware changes. Testing and development. So ideal for software development and testing, as developers can create separate environments without impacting production systems. Disaster recovery. VMs can be backed up and restored quickly, facilitating effective disaster recovery solutions. Next one is the use cases of virtual machines. Development and testing. So developers can create multiple environments to test applications across different OS configurations. Server consolidation. Organizations can reduce physical hardware by consolidating multiple servers into VMs on fewer physical machines. Cloud computing. So many cloud services like AWS, Azure rely on VMs to deliver scalable computing resources. Legacy application support. So run older applications that require outdated operating systems without maintaining legacy hardware. Training and education. VMs provide a safe environment for learning new technologies without risking the host system. Next is the managing virtual machines. So in this topic we are going to cover creating VMs, snapshots and cloning, resource allocation. So creating VMs. Use a hypervisor to create new VMs, allocating resources and installing guest operating systems. Snapshots. So take snapshots to save the current state of a VM, allowing easy rollback to a previous state if needed. Cloning. Create copies of VMs for testing or scaling purposes. Resource allocation. Monitor and manage CPU, memory and storage resources assigned to each VM to ensure optimal performance. So what are all the challenges and considerations now facing are performance overhead and complexity security. In performance overhead, VMs may introduce some performance overhead compared to running directly on physical hardware, particularly with Type 2 hypervisors. Complexity. Managing multiple VMs can lead to complexity requiring robust management tools and practices. Security. While VMs are isolated, vulnerabilities in the hypervisor can potentially expose all VMs to risk. So in conclusion, virtual machines are a powerful tool in modern computing, offering flexibility, efficiency and scalability. Understanding how VMs work, their architecture, benefits, and use cases can help us to leverage virtualization technology to improve operations, enhance development processes, and optimize resource utilization. Thank you.